Okay, so now I will be going over question 32. So the important concept in question 32 is first angular momentum. Okay, so basically, angular momentum is the quantity of rotation of a rotating body. There are two types of angular momentum. The first type is L, that's the variable we use for angular momentum, is equal to m times v times r, mass times velocity times the radius, and that's when an object is rotating around something else. So, for example, like when the Earth rotates around the sun, that angular momentum can be expressed as m times v times r. And the other type of angular momentum, the one that we're going to be discussing in this question, is L equals I, which is moment of inertia, times the angular velocity. So I'm just going to write that down. And basically, this is when an object itself is rotating. So let's say, for example, when the Earth rotates around its axis, just like rotating around its axis, that is angular momentum. That's the type of angular momentum, moment of inertia times angular velocity, and that's the one we're going to be using in this question. Okay, so the next concept I will be going over is moment of inertia. I'm just going to be showing this concept in order to explain more of this angular momentum. So the equation for moment of inertia is I is equal to mr squared, mass times radius squared. And basically, moment of inertia is a quantity expressing a body's tendency to resist angular acceleration. So, like, inertia is basically resisting change in motion. And so, moment of inertia is basically the angular portion or the angular side of inertia. A body's tendency to resist angular acceleration. Okay, so those are the two important concepts in this question. So now I'm going to read question 32. But first I'm going to read the greater overview for questions 31 through 32. A particle of mass m moves counterclockwise around a horizontal circle of radius r, as shown above. The angular speed of the particle is given as a function of time, t, by angular velocity is equal to b times t, where b is a positive constant and t is greater than 0. What is the magnitude of the angular momentum of the particle about the center of the circle as a function of time? Okay, so in this question, they are asking for the angular momentum. And since, well, I'll draw a picture of the object, but basically it's like this, and the object is rotating like that. It's going to be, and it says like of the particle about its center of circle. That means it's going to be the angular momentum equals I times angular velocity, moment of inertia times angular velocity. So that's the type of angular momentum we'll be using for this. Okay, so first I'm just going to write down L equals moment of inertia times angular velocity. And then, so now I can plug in moment of inertia into the equation. So I'm going to do L equals, and I showed above, mr squared times angular velocity. And in the overview for this problem, it says the angular speed of the particle is given as a function of time t by, and then it says angular velocity as a function of time, they say here, is equal to b times t. So that means I can plug this into here, and through the answers to this question, it shows b and t. So that kind of gives me an indication that I'm able to plug those these into here. So then I can do L is equal to mr squared times bt. And so then the answer for this problem is C, and it basically just rewrites it a little bit, but it's just mbr squared t, which is basically just moving around the variable. So basically this question, so then the correct answer to this question is C, because here. So basically this question is just plugging in what we know and using equations that we know to solve for angular momentum. Uses important principles of moment of inertia, also angular momentum, and specifically angular momentum when an object is just rotating around its axis, which is what's happening here. And we can just plug in what we have, and that will get us to the correct answer, which is C.